Okay, so we've all talked to a chatbot, right? They can answer questions, maybe tell a joke, but what if they could do more? A lot more. In this explainer, we're going to break down the incredible leap from an AI that just talks to an AI that actually does things. We're talking about giving AI hands to interact with our world. Let's get into it. You see, large language models, LLMs, are brilliant, no doubt, but they have this one huge problem. They're fundamentally trapped. They're trained on a massive but static pile of data. That means they have no idea what the weather is right now. They can't book a meeting on your calendar or pull live sales data from your company's database. So this is all about the tech that's finally setting them free. Probably the best way to get your head around this is the whole brain in a jar idea. A standard LLM is exactly that. A super smart brain, but it's totally isolated. Its knowledge has a cutoff date, and all it can do is spit out text. It's passive. But an agentic LLM, that's a brain with hands and eyes. It can tap into live, real-time information, and this is the game changer, it can actually execute tasks. It goes from being a source of info to an active player in your workflow.
All right, so how do we actually do it? How do we get that brain out of the jar and give it hands? Well, the solution is to give the AI a set of tools it can use to reach out and interact with the digital world. This is what bridges that huge gap between understanding what you want and actually getting it done.
Okay, so the big idea, the high-level concept, is something we call tool use. You can think of this as the overall strategy. We're basically giving the LLM permission to use outside help. Anything from a search engine to your company's internal API for booking conference rooms. It's the what the AI is allowed to do. So if tool use is the what, then function calling is the how. And this is the really clever part. The LLM doesn't write or run any code itself, no way. Instead, it cooks up this really structured request, usually in a format called JSON, and that request basically says, hey, application, can you please run this specific function for me with these exact details? And this quote just nails the shift in thinking here. This is a total paradigm shift. We're not just calling an LLM to get some text back anymore. The LLM is now the central brain, the conductor of the orchestra that figures out which tools it needs to call on to get the job done. Okay, so let's get into the nitty-gritty. How does this back and forth between the AI's brain and the application's hands actually work? It's not magic, it's a really clear logical loop. Let's walk through it. It all boils down to this simple three-step loop. First, the request. The LLM analyzes your prompt, realizes it needs a tool, and generates that structured call. Second, execute. And this part is absolutely critical for security. The application, not the LLM, receives that request and runs the actual code. Finally, respond. The application sends the result, whether it succeeded or failed, back to the LLM. The loop is now closed, and the AI has new info to work with. I'm going to say it again because it is that important. This separation is the most critical design choice here. The LLM is the brain. It does the reasoning. The application has the hands. It does the executing. The LLM never runs code directly. This creates a natural, secure sandbox that keeps your application in full control. Of course, anytime you give an AI powerful new toys, you also create brand new ways for things to break. Building these agents so they're tough, reliable, and secure is a huge engineering challenge. You can't just cross your fingers and hope for the best. You've got to plan for things to go wrong. You see, LLMs aren't like normal computer programs. They're a bit fuzzy sometimes. They're non-deterministic, which means they can make mistakes. It might just hallucinate a tool that doesn't even exist. Or it could get the arguments wrong, using city when the function needs location. It might even give you the word 5 instead of the number 5. So developers have to build guardrails to catch all of these potential slip-ups. So what's the best practice when this happens? Well, you definitely don't want the whole thing to just crash and burn. The most clever solution is to catch that error and feed it right back to the LLM as what's called an observation. It's like telling the AI, hey, that last thing you tried, it didn't work. Here's the error message. Read the instructions again and give it another shot. This creates this awesome self-correcting loop where mistakes actually make the AI better. And from a security point of view, you have to treat the agent itself as a potentially untrusted user on your system. This means following some time-tested security rules. First, least privilege. Give the agent the absolute minimum permissions it needs to do its job and nothing more. Run risky stuff in a sandbox environment. And for really high-stakes actions, like, deleting a database or sending money, you always want a human in the loop to give that final okay. All right, so we've got one agent with hands. That's cool. But where this gets really mind-blowing is when we go from simple automation to full-on collaboration. We're now using these exact same building blocks to create whole teams of specialized AIs that can work together to tackle really complex problems. A huge step forward here is something called parallel function calling. Just think about it. If you're planning a trip, why would you ask an AI to find a flight, wait for that to finish, and then ask it to find a hotel? An advanced agent can see those are two separate jobs and request both at the same time. This is a huge deal because it slashes waiting times and makes the whole experience feel way faster. And to build these sophisticated systems, some really powerful frameworks are starting to emerge. You've got things like LangGraph, which lets you map out complex agent workflows like a state machine, giving you total control. Then there's AutoGen from Microsoft, which gets different AI agents to talk to each other to solve a problem. And Crew AI, which lets you assemble a team of role-playing agents, say a researcher, a writer, and an editor, to work together on a task. But let's bring this back down to earth for a second. The agents that are actually succeeding out in the wild today, in real companies, they aren't some all-powerful do-everything AI. Not at all. They are specialists. Think customer support agents that know a product inside and out, or internal tools that automate one specific workflow. The most valuable agents right now are highly focused and designed to work with human experts, not replace them. So as we look to the future, the picture is becoming really clear. It's not about building one single monolithic super AI, it's about creating a collaborative ecosystem, a team of highly specialized agents, each with its own skills and tools. And that leads me to the final question for you. If you could build your own crew of AI agents, what big problem would you want them to solve?